Hello, very good evening, guys. Welcome to BYJU'S exam prep. Good evening, all of you. Good evening, very good evening. I hope everyone is good, fine. Good evening, guys. Good evening. Okay, so today we're gonna practice questions from the subject of heat transfer for the ISRO examination, which will be commencing next Saturday, right? Next Saturday or Sunday? Next Sunday, right? Huh? So definitely you need to buckle up and need to increase your practice level. है ना? So yesterday we have solved question from the theory of machines. So today we'll be solving question from the heat transfer. Heat transfer is actually an important subject. Like normally 6 to 7 question is being asked from this subject every year. Like इसरो जब भी conduct किया है 6 to 7 question आपको हमेशा देखने को मिलता है. And that too very straightforward and very easy. Okay. So please do confirm audio and video में कोई दिक्कत तो नहीं है. All good. Hello, very good evening, guys. Good evening. Let me check. I think all good. है ना? Okay. Good evening. Very good evening. Fine. तो जैसा कि इसरो एग्जाम के लिए yesterday we have practiced the questions from the theory of machines. So today हम लोग बात करेंगे heat transfer subject की, a very scoring, a short and easy subject. So hello Hari. Good evening. Very good evening. Okay. All good. Yes, all good with audio and video. Yeah, perfect. Chalo, so shall we begin? Yes. One second. One second, guys. Perfect. हाँ, अब ठीक है? No issue with audio and video, right? चलिए, तो let's begin our practice session, the heat transfer mock test. That is Sunday. आज हम लोग बात करेंगे. And I hope so. कल आप लोगों ने you all have downloaded the PDF. I've already shared the theory of machine PDF. You have downloaded from my Telegram channel, that is Mechanical by Suraj. Okay, and if you have any doubt or difficulty, you can drop me a mail at suraj.s9@byju's.com, which you are seeing, and you can download this PDF for future reference also, right? Okay, clear. Gate practice crash course, which was started on 4th of December. The complete schedule, if I say tomorrow, you will be practicing the questions from the fluid mechanics, and that too all the gate level questions, not ISRO level. ISRO में थोड़ा सा gate से थोड़ा सा कम level they are asking, right? So already we have covered all these sessions. Now on Monday 5 p.m. Chandra Striker sir will be coming up live and he'll be discussing about the fluid mechanics के important questions for the first week of the schedule for the crash course. Okay, and along with that, iske alawa, if you want to practice for ISRO examination, you can do download the app where you will be getting free mock tests or free quizzes, subject wise tests for the ISRO examination. And definitely you should be going through these questions. The reason being क्योंकि इस समय you need to concentrate on more practice, more revision. है ना, whatever you have studied, just be consistent, be restrict yourself to those subjects only. Do not take up any new subjects at this point of time, because a week is left out for the examination. So definitely you need to now concentrate on the practice and revision. That's it. Okay, chaliye. So already, just like I told you, a 3 session was planned. Yesterday we had a theory of machine. Today we'll be talking about heat transfer, and tomorrow we'll be talking about the engineering mechanics. This is a tomorrow 6 p.m. session. 6 p.m. on Monday, tomorrow, right? So definitely you will be joining same timing. I'm not changing the timing so that you're not having any difficulty in the change of timings. Okay, so let's go with the first question on the screen. And let us see who's gonna give me the first answer. Uh, the temperature variation in a plane slab is given by a temperature profile T is equal to 80x square plus 70x plus 150. If the thermal diffusivity alpha is equal to 0.5 meter square per second, then what is the rate of change of temperature? They're asking you what is the value of del T by del small t. Anyone? There is no heat generation being done, so definitely we can take Q dot equal to 0, and you can go for the generalized one-dimensional heat conduction equation. Quickly, option A, B, C or D, and these type of questions should not be taking much time. जैसे कल हमने किया था, है ना, just like we have studied solved question yesterday. Hello Kiran, good evening, good evening. So similar pattern we have to go with the same pace, क्योंकि ISRO में time and accuracy both is important. Correct, very good Kiran. Hari. Yes, what is your answer? The first question is on the screen. You have to apply the one dimensional heat conduction. Okay, if you try to apply the one dimensional heat conduction equation, right, that will be equal to del 2 T by del x square plus q dot by k is equal to 1 upon alpha del T by del small t. As they are not mentioning anything about heat generation, this will be tending to 0. So we can say del 2 T by del x square is equal to 1 upon alpha del T by del small t. Right. So we have to differentiate this 2 times. So if I try to differentiate del T by del x, that is equal to 160 x plus 70. Again differentiate del 2 T by del x square, that is equal to 160. Now place this over here. So del T by del small t is equal to 160 into alpha is given as 0.5, thermal diffusivity 0.5, that is coming out to be 80 Kelvin per second. Option A is the correct answer. Option A is a correct. Very good. Kiran has given me the answer. Hari, what is your response? Is this clear? देखो यार, ISRO, for ISRO examination heat transfer is actually having a good weightage, so try to revise heat transfer, small subject, and you can definitely revise this very easily, है ना? So do not skip up this subject of heat transfer. Very small, very easy and scoring subject. Okay, everyone. Very good evening. Yes, yes, done. Option A is a correct answer. Okay, perfect. Next question number 2 on the screen. The temperature variation under steady state heat conduction across a composite slab of two materials K1 and K2 is shown below. Which of the following is the correct answer? So they basically have given two slabs, right? And they are having the equal thickness, like L by 2 and L by 2 is being given. K1 and K2, the temperature difference is given as 120, 90 and 30. That's not temperature, that's exact temperature being given. So they're asking you, in this composite slab, what is the relation between K1 and K2? Yes, the thickness is, let me write it over here, this is L by 2 and L by 2. You might not be able to see this, so L by 2, L by 2 is the same thickness. Is it option A? Is it option B? Is it option C or option D? Quickly, option A, B, C or D? Which of the following is giving us the correct combination with the, we can say, the thermal conductivity? Yes, Kiran, Hari, quickly everyone. And let us see who's going to give me the answer. Option A, B, C or D. Option A. Okay, Hari is going with option B. Very good. Now this is a series connection. है ना? Series connection में we have the same heat flow. So we can see, if I try to draw the network diagram, this will be something like this. यहाँ पे 120 डिग्री सेल्सियस, यहाँ पे 90 डिग्री सेल्सियस एंड यहाँ पे 30 डिग्री सेल्सियस. ठीक है, तो वी कैन से द हीट ट्रांसफर दैट इज डेल्टा टी बाय L by 2 into K1 into A is equal to delta T2 K2 into A upon L by 2. Everything will be cancelled out. This one, this one, this one, this one. Delta T1 is 120 minus 90 is 30 into K1 is equal to 90 minus 30 is 60 into K2, right? So we can say K1 is equal to 2 times of K2. Option B is the correct answer. Kiran, no, option B is the correct answer. K1 is equal to 2 times of K2. Okay, very good, Hari, correct answer. Perfect, very good. Clear? हाँ, very good, very good. चलिए next question. I hope so this is clear. This is a very easy question. You just need to apply the your resistance analogy, electrical analogy, calculate the resistance for the individual slabs, and you can equate this. Okay, fine, no problem. Next question, question number 3. Two walls of same cross section area, same thickness have thermal conductivity is a ratio of 3:4. So K1 by K2 is equal to 3 by 4. And the temperature drop across the two walls is given delta T1 by delta T2 is equal to 4:1. What is the ratio of the we can say ratio of the heat flow across the wall? That means Q1 by Q2 they are asking. Quickly, simple question. What is the value of Q1 by Q2? Use Fourier's law of heat conduction and tell me the final correct answer. Very easy, scoring hai. 15 seconds I think will be sufficient enough to solve this question. Everyone, option A 1 by 2, option B 3 by 1, option C 2:1 or option D 3:2. Very good, D. Yes, Hari, all of you, please do let me know. We know that what is Fourier's law of heat conduction? Q is equal to KA del T by L, है ना? Fine. Let's say Q1 K1 delta T1 divided by Q2 K2 A delta T2 by L. So everything will be cancelled out, only K1 by K2 and T1 by T2 will be left out. So we can say Q1 by Q2 is equal to K1 by K2 into delta T1 by delta T2. That's it. So what is K1 by K2? That is 3 by 4. And what is delta T1? That is 4:1. That is equal to 3:1 is the correct answer. Option B is the correct answer. Very good. Option B is the final correct answer. Okay. Perfect. Very good. Done. Next question. Can we proceed? Option B is the correct answer. Chaliye. Next question on the screen. Question number 4. Very easy. A very scoring. Multiple number of times this question is being asked in the ESE, in the different PSU examination also. If A1 and A2 are the internal and the external surface areas of the hollow cylinder, what is the logarithmic mean areas is given by? A, B, C or D? It's a very direct, straightforward. Now, there is one option you can directly eliminate. Option B is not possible. And option B is not possible. Shan is going with option A. Kiran with C. Hari, option B, sure? It's a very easy, just you have to have a resemblance or we can say analogy between a hollow cylinder with a slab. Okay? C. Okay. Chaliye, let's draw this diagram. This is a hollow cylinder, the side view. This is R1, this is R2 and this is having K. So this is K, this is having R2 minus R1 as a thickness. Let's say the cross section area is AM. Okay, what is the your resistance for this one? This is Ln R2 by R1 divided by 2 pi K into L, where L is the length of the cylinder. That is equal to your R2 minus R1 divided by K into the mean area, right? K get cancelled out. So the mean area will be equal to 2 pi R2 into L minus 2 pi R1 into L divided by Ln R2 by R1. You can multiply divide by 2 pi L in this. So we can get this is A2 minus A1 divided by Ln of A2 by A1. So this is the logarithmic mean area of a hollow cylinder and I think you are getting option C as a correct answer. Option C. Shan, Vicky, option A. After ISRO के बाद करेंगे, है ना? ISRO एग्जाम के बाद कंडक्ट कराएंगे, डोंट वरी. एक मैराथन सेशन करा देंगे वाइब्रेशन का, सिर्फ वाइब्रेशन का टॉपिक, ठीक है? क्योंकि आई वांट कि आप लोग पहले कंसंट्रेट करो पीएसयू एग्जाम जो होने वाले हैं अभी नेक्स्ट वीक, तो उसके बाद विल बी कंसंट्रेटिंग डेडिकेटली ऑन द गेट एग्जामिनेशन. ओके, चलो नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 5 ऑन द स्क्रीन. A cold liquid enters a counterflow heat exchanger at 15 degrees Celsius at a rate of 8 kg per second. The hot stream of the same liquid enters the heat exchanger at 75 degrees Celsius. That means your cold inlet temperature is 15 degrees Celsius and the hot inlet temperature is 75 degrees Celsius. Okay. Now, they have given that your mass flow rate of the cold fluid. Mass flow rate of the cold fluid is equal to 8 kg per second and mass flow rate of the hot fluid is equal to 2 kg per second. So they're asking you what will be the maximum heat transfer, A, B, C or D. Specific दोनों के लिए same होगा ना? The CP value for both the fluid is same because the same fluid is being used, that is 4 kilojoule per kg Kelvin degree Celsius. A, अच्छा, A with Hari, Kiran with D, anyone? एक छोटा mistake करेंगे, you'll be getting the wrong answer. As simple as this. One small mistake and you'll be getting the wrong answer and that wrong value is there in the options. ये भी आपको बता देता है. आप कोई calculation mistake करेंगे तो definitely you'll be getting a wrong value और wrong value is available in the option. देखो, what is the maximum heat transfer in a heat exchanger? Q maximum is equal to the minimum heat capacity rate into the maximum temperature difference, that is hot inlet minus cold inlet. यही होता है. Now we need to identify which will be having C minimum. बताइए hot या cold? What is C? That is equal to product of mass flow rate into Cp. अब देखो cold fluid is having 8 kg per second, hot fluid is having 2 kg per second, both are having the same fluid, so we can say CH is your C minimum, है ना? We can say CH is your C minimum, right? So we can say CH is 2 into 4 into 75 minus 15. What is the value? 8 into 60. 6 8s are 48. 480 kilowatt. Option D is the correct answer. 480 kilowatt. Option D is the correct answer. Okay. Clear? हरी कहाँ कैलकुलेशन मिस्टेक कर दिया? एक दो 2 टाइम्स आंसर आ रहा है आपका. विकी डन. क्लियर है एवरीवन? ऑप्शन डी इज द करेक्ट आंसर. ओके, चलिए नेक्स्ट गो विद द नेक्स्ट क्वेश्चन नंबर 6. आई होप सो दिस इज क्लियर. नेक्स्ट क्वेश्चन नंबर 6. What is the ratio of actual heat transfer from a fin? We are talking about fins, right? For fins, the actual rate of heat transfer to the maximum possible heat. What do we call this ratio for fins? Is it called effectiveness, efficiency, fin performance coefficient, or convective coefficient? A, B, C or D? इसमें भी confusion होता है बहुत लोगों को. देखो, if I talk about the efficiency of the fin, efficiency is the actual by maximum. This is the efficiency of the fins. If I talk about effectiveness, that is Q with fins by Q without fins. Without fins. This is the effectiveness of the fin. If you're using a fin, if you're not using a fin, then what is the ratio? That is basically now, according to this, option B is the correct answer. Very good, Narendra. Narendra is correct. A is not correct. Effectiveness, जो ये वाला formula है ना, Q actual by Q maximum for fins, it is the effectiveness. Okay. Very good, very good. Prabhu correct. Vicky. Exactly. Very good. और ये सब questions है ना, you will be having a quick revision of your subject only. That's it. My main objective is to revise your subject for the examination. चलिए next question. Option 7, question 7 on the screen. I hope so this is quite clear. Fin performance coefficient or convective coefficient करके कुछ नहीं होता in terms of fins terminology. Okay, next question. In unsteady state conduction for bodies with negligible temperature gradient. Now, by this statement, what they are basically talking about? Negligible temperature gradient means they are talking about lumped body. They are talking about lumped body. Now, question is, what is the time temperature variation curve? It is a linear, parabolic, exponential, or sinusoidal. Let us suppose you have heated up a body. So, with that time, what will happen? The temperature will decrease. So, is it linear, parabolic, exponential, sinusoidal? Option C is the correct answer. Very good. You might have seen this kind of temperature variation. Okay, this is T and this is your time. Temperature versus time is the graph they are asking. This is for cooling of a body. For heating of a body, we can have a temperature like this one. Okay, this is T versus time. This is the cooling of a body. This is the heating of a body. And I hope so you know about that formulation. For lumped body, T minus T initial minus T T minus T infinity upon T initial minus T infinity is equal to e to the power minus HA by rho V Cp into T. Right? I hope so you know about this formulation. T minus T ambient temperature divided by T initial minus T ambient, that is equal to e to the power minus HA rho V Cp into T. This we are using for the lumped body. That is an exponential decreasing term. With the time, the temperature will decrease in an exponential way or increase in an exponential way. Okay, chaliye next question, question number 8 on the screen. In a counterflow heat exchanger, same heat capacity for the two fluids they are using. Okay, they are using CH is equal to C, right? That means C is equal to 1. C minimum by C maximum is equal to 1. The hot fluid, and that too I am talking about counterflow. The hot fluid is cooled from 150 to 70 and cold fluid is heated from 20 to 100. What is the log mean temperature difference in Kelvin? What is the log mean temperature difference in Kelvin? Quickly बताइए. Anyone? 1 second guys. Option A, B, C or D. You have to answer in Kelvin. So basically this is a case of your we can say balanced heat exchanger. Balanced heat exchanger, right? And we know that for balanced heat exchanger in a counter flow, the temperature profile is linear and parallel, something like this. Perfect, very good Narendra, perfect revision चल रहा है, बहुत बढ़िया. Hot inlet, hot outlet, cold inlet and cold outlet, right? This temperature is given as 150 degrees Celsius. This is your 100 degrees Celsius. Uh, then your hot outlet is 70 and this is 20. So if I try to take the difference, this is 50 degrees Celsius, this is also 50. So tell me what's the answer in Kelvin, 50 Kelvin or what we have to go with the final answer? Option A, B, C और D. यहाँ confusion होता है. देखो delta Ti is equal to delta To is equal to 50. Now tell me, this is degree Celsius. Okay. So what is the final answer? Shall I go with option C or option A? देखो यार, this is temperature difference. Even if you are writing in Kelvin, that is also correct. Because temperature difference में Kelvin degree Celsius का कोई importance नहीं होता. Okay, because they are talking about temperature difference. So in temperature difference, you can write in degree Celsius also, you can write in Kelvin also. It is immaterial. So option C is the correct answer. Is this clear? Option C. Very good. Students do have confusion in a hurry. They calculate in degree Celsius and they add 273 and they're landing with the wrong answer. And that wrong value is also available, 323. That wrong value is also available in the option. Right? Okay. Option C is the correct answer. A is not the correct answer. Okay. Chalo, next question. Ninth question on the screen. The temperature of a surface with 0.2 meter square area is having a temperature of 17 degrees Celsius. Calculate the wavelength corresponding to the maximum monochromatic MSE power. You have to calculate the wavelength corresponding to the maximum monochromatic MSE power. Option A, B, C or D. Very easy question. Achha, which law you have to use? Can you tell me? Which radiation law you have to use to get the answer? Anyone? Ninth ka C. Okay, Madhu. Very good. You have to use this one. Weis displacement law. Okay. Sir, in PYQ of ISRO, I have seen they give some question random question topic. That should be attempted at the last. If you are having time, you can go for that, Narendra. But try to first of all cover all the topics, all the questions which you know in the first go. Okay, you have to go with that. Because sometimes in ISRO, I have seen that they are asking question from topic which you might not have studied also. ठीक है, ऐसा भी देखा गया है, right? Every year or every alternate year you might be having this kind of scenario. So don't worry, you have to concentrate on first of all those topics which you are having a strong point. Then you have to go for those topics technical part. Okay, so we can say lambda m into T is equal to 2900 approximately. 2898 is a value. We can take approximately 2900. So this temperature can be written as 290 Kelvin, 290 Kelvin. So lambda m is equal to 290. This will be 290, that is equal to 10 micrometer. Okay, so option C is the correct answer. वैसे in actually it is lambda is equal to 2898 micrometer Kelvin. This is the actual value, but we can round off to our 2900 for easy calculation. Okay, option C is the correct answer. I hope so everyone has given option C. Madhu correct, Kiran correct, Ravi, Narendra, Hari, D is not correct. हाँ, that I know. I have seen last year में एक बार question था, and that was not even the syllabus of GATE or ESE, right? उस case में it is same to all the students. ठीक है, वो question सभी के लिए new होगा, so don't worry about that. You have to concentrate on the rest of the topics. बाकी में थोड़ा concentrate करो. Okay, चलो next question number 10th on the screen. अरे कहाँ गया? One second. हाँ. A saturated vapor is condensed to a saturated liquid in a heat condenser. The effectiveness of the heat exchanger is if the number of transfer units is equal to 1. They are giving that NTU is equal to 1. Then what is the value of effectiveness? They have not mentioned anything about the heat capacity rate ratio. Now, as this is a condensation operation, condensation में can you tell me which fluid is undergoing phase change? Because definitely there is a phase change phenomena. Whenever a heat exchanger, a fluid is undergoing a phase change phenomena, we can say the C value is tending to 0 because C minimum, C maximum is tending to infinity. So we can say condensation means hot fluid is undergoing a phase change. If I say this will be the temperature profile, something like this, और उसमें parallel हो या counter हो, it is immaterial, है ना? It could be parallel counter क्योंकि phase change में parallel and counter both are giving us the same results. Okay, what is the final answer? Kiran, Narendra, very good. Anyone else? Option B. Can we lock option B now? Okay, Madhu is going with option C. Okay, anyone else? Now we have a mix of answer. Archana, good evening. Option B. Okay, perfect. B है, B है, very good. B. So majority are going with option B. देखो 1 minus e to the power minus NTU is equal to effectiveness. Okay. अच्छा कल पूछा था क्या? I didn't knew. I have not seen the paper. So 1 minus e to the power minus 1 and that is equal to 0.632. Okay. 1 upon E is 0.39, 0.36 actually, 0.368. This will be 1 minus 0.368. Solve it, you'll be getting this one. Option B is the correct answer. That is the reason I told you, na, whenever you are practicing for any of the PSU, specifically I'm talking about PSU, not the GATE examination, आप एक की तैयारी करेंगे, automatically you are preparing for the rest PSU examination because the level of questions for all the PSUs is quite basic, except BARC. Rest all the PSUs examinations are quite basic, so definitely you will be able to solve questions very easily. Okay, chalo next. I hope so. A counterflow heat exchanger is used to cool oil having Cp value flowing at 0.5 from 120 to 45 by the use of water. The inlet and the outlet temperature of the cooling water is 10 and 70 degrees Celsius. What is the effectiveness of the heat exchanger? This is one of the type of question usually asked in the GATE also. GATE they are asking. So what is the effectiveness? Now we know one formulation. What is effective? That is Q actual by Q maximum. Q actual could be the heat lost by the hot fluid or the heat gained by the cold fluid. Now what is Q maximum? Q maximum is nothing but your C minimum into the maximum temperature difference, that is delta THI minus TCI. Okay, fine. So C minimum किसका होगा? तो just we have to calculate. We can say using energy balance. कुछ नहीं, देखो कुछ नहीं करना, बहुत easy है. Don't go for heavy calculations. For energy balance, we know that CH into THI minus THO is equal to CC into TCO minus TCI. D. Okay, Narendra is going on option D. CH को ऐसे रहने देते हैं. THI hot inlet is 120 minus 45 CC into 70 minus 10. So this is how much? 75 है ना? This is 75 and this is CC into 60. So by this we can say CH is your C minimum. The hot fluid is a C minimum, right? अगर hot fluid C minimum हो गया, now we can say effectiveness is equal to Q actual by Q maximum. So we can say CH into THI minus THO by C minimum into THI minus TCI. तो ये दोनों cancel out हो गया. What is THI? Hot inlet is 120 minus 45, 120, cold inlet is 10. So this is 75 by 110. What is the nearest value we're getting? Option A, B, C or D? Yes, 0.68, somewhere around 0.681, somewhere around 0.681. Option D is the correct answer. Very good, Narendra, correct. Sir, any tips to solve the value? नहीं देखो, इसमें तो आपको एक चीज बता देता हूँ. Always go for the approximation, right? You have to remember some set of values. अगर if you are knowing 1 upon E, like 1 upon E is 0.3, 0.36. 1 upon E is 0.3. You have to remember this 0.363 basically. Oh, 0.368. ठीक है, तो वो याद रखिएगा. 0.36 you can remember, and from there you can calculate. देखते हैं अमित, देखो वो तो वेट करना पड़ेगा आपको, है ना. So if they have given the date of examination तो जल्द ही आने वाला है. राइट, सो डोंट वरी अबाउट. पहले तो हम लोग डेट ऑफ एग्जामिनेशन का वी वर वेटिंग, नाउ डेट ऑफ एग्जामिनेशन बीइंग रिलीज. सो चलो ठीक है, नेक्स्ट क्वेश्चन. Okay, match the list 1 and list 2. On list 1 we are having the type of heat exchanger, and list 2 we are having the temperature profile, right? A option is, let me read out list 1, counter flow, parallel flow, option C is evaporating, and option D is condensing. चलिए बताइए. I've just shifted myself, थोड़ा मैं left हो गया हूँ, है ना? What is the correct combination, A, B, C or D? Which of the following is the correct combination with the counter, parallel, evaporating or condensing? D is condensing, C is evaporating, B is parallel flow or A is counter flow. बस combination देखिए and tell me the answer. And tell me, frankly speaking, अगर आप सिर्फ parallel और counter को देखेंगे ना, you'll be able to, counter को देखिए, parallel को देखिए, you'll be able to solve it. इनमें से जो भी आपको दिख रहा है ना यहाँ पर options, उसमें से देखिए, you'll be able to solve it quickly. Madhu, very good. Option A is correct. Option A is correct. Now, this is a this is a counter flow. So A3, A3 बोले तो this is eliminated. This is eliminated. This is parallel flow. B4 हो गया. बाकी देखना भी नहीं है. Whenever you're getting any question like this, na, match the following, चाहे वो कोई भी exam हो, try to eliminate the option that will be giving you quick answers, even if you don't know the other two options. Let us suppose evaporating नहीं पता, condensation नहीं पता. Condensation मतलब hot fluid will be changing the phase. This is the condenser, and this is the evaporator. ठीक है. Option A is the correct answer. अर्चना, गलती से C हुआ है, I suppose, है ना? A is the correct answer. Okay. Done. Next question number 13 on the screen. Hari, Kiran, Amit, very good. Narinder, done. देखो इसके बारे में we have already discussed, and I hope so you can tell me the answer as soon as possible. In a balanced counter flow heat exchanger where the heat capacities of both the fluids are same, that is hot fluid और cold fluid का heat capacities are equal, मतलब जो ratio है that is equal to 1, C minimum by C maximum. So which of the following is the correct answer? Balance भी बोल रहा है, counter flow भी बोल रहा है, इतना information दे दिया, so definitely we can go with option B, because we know that for this one it is having a parallel lines temperature profile. This is T hot inlet, T hot outlet, T cold inlet, T cold outlet, and we know that the temperature difference at the inlet and the outlet will always be remaining same. Okay, the delta Tm is equal to delta Ti minus delta T is equal to delta TO. Okay, right? B option is the correct answer. Next question number 14 on the screen. चलिए बताइए. From radiation shielding, two infinite parallel plates are placed at a certain distance apart. The heat transfer between the plate is reduced by 90%. 90% तक you have to reduce. Then the number of radiation shield required to be inserted between the same plates, considering both the shield and the plates are having the same emissivity. Special case, याद है? Special case. N plates, N shields basically. Yes, A, B, C or D. This is N shield. These are plates. Okay. D, B, अच्छा C और D में confusion हो रहा है. C और D में confusion हो रहा है. Okay. देखो, if you you know the formulation, Q with shield is equal to Q without shield divided by N plus 1, where N is number of shield. Now if I want to reduce by 90%, that means 0.1 times, है ना? अगर आपको 0.1 time करना है, so if I take N is equal to 9, then I can say that Q with shield will be equal to Q without shield divided by 9 plus 1, that is equal to 0.1 times Q without. That simply means the 90% drop has happened. There's a 90% drop in the heat transfer, so option D is the correct answer. If you are using 1, then you will be dropping by 50%. 1 by 2, 50%. Okay? If you are, let us suppose you are using 3, so 1 by 4 is 0.25, 75% will be dropped. If you are using 4 shields, so 1 by 5, 0.2, 80% will be dropped. and if you're using 9 shields, 1 by 10.1, 90% is being dropped. Okay, so option D is the final correct answer. Clear, Amit? Perfect, very good. Option D is a correct answer. Okay, clear है? अरे नरेंद्र क्या हो गया? Option D is the correct answer, not A. चलिए next question, question number 15. Two surfaces A1 and A2 of a body are analyzed for the heat transfer. If the areas of the surface are 300 mm and 150 mm square, so A1 is equal to 300 mm square and A2 is equal to 150 mm square, right? What is the nature of surface 1 when A2 is completely enclosed by A1? So let's suppose this is A2 and we are having this as A1. Okay, because they have already mentioned F22 is equal to 0. So they are asking you what is the nature of surface 1? Is it a flat surface, convex surface, concave surface or a shiny surface? Shiny surface हम कुछ बता नहीं सकते, A, B और C में से we can go with the answer. So we can say F21 is equal to 1. We can use reciprocity theorem and tell me what's the value of F12. If you use reciprocity theorem, F12 A1 is equal to F21 A2. So F12 will be equal to 1 into A2S 150 and divided by this is 300. So this is 0.5. So F12 is 0.5. So we are getting F12 not equal to 0, F12 is less than 1. That simply means that is a concave surface. Concave surface. Option C is the correct answer. क्योंकि flat surface के लिए F11 will be equal to 0. Convex के लिए भी F11 will be equal to 0. But here if I try to calculate what is F11, F11 will be equal to 1 minus F12, that is 0.5. So F11 आपका 0.5 आ रहा है, it is not equal to 0, right? So option C is the correct answer. Concave surface. Clear है? Very good. राइट दोनों में आपका F11 0 आना चाहिए, चाहे फ्लैट हो या कॉन्वेक्स हो. कॉन्वेक्स कुछ ऐसा होगा, देखो ऐसे करके. सो इट विल नेवर हैव एनी वी कैन से सेल्फ शेप फैक्टर. ठीक है, ऑप्शन सी इज द करेक्ट आंसर. वेरी गुड ऑल ऑफ यू. मधु, किरण, अमित, अर्चना बी कैसे? स्टार्टिंग में यू आर गिविंग मी करेक्ट आंसर्स, अब एकदम से क्या हो गया? ऑल गुड. नरेंद्र डन. Okay, next question, question number 16. I want everyone to respond this correct answer because this is the most easiest question. I assume that for today's session. As a wavelength increases, the monochromatic emissivity of gray body, what is that? Increase, decrease, independent of wavelength, first increase then decrease. As wavelength increases, what is happening with the monochromatic emissivity? Option C. Very good. We know that is the property of a gray body. We know that for a gray body, your monochromatic emissivity is not a function of lambda. It is independent of lambda. That is a property of a gray body. So from here we can say option C is the correct answer. Option C is the correct. Very good all of you. Shiva, Kiran, Amit, Ravi Ranjan, बहुत बढ़िया. Very good. Madhu, क्या हो गया? Now you are giving me wrong answer. Option C is correct. Okay. 17th question. A diffuse radiation surface. What is a diffuse radiation? Anyone? A diffuse radiation surface has radiation intensity independent of angle, radiation intensity dependent on angle, radiation intensity dependent on wavelength, radiation intensity both dependent on angle and wavelength. Independent on angle and wavelength. Which of the following is correct answer? 17th, very good Shiva, correct answer. देखो basically there are three types of, we are talking about the intensity of radiation. We are talking about the intensity of radiation. ठीक है, ये जो radiation intensity की बात कर रहे हैं, that is the intensity of radiation, right? And we know there are three types of surface. One is a diffuse surface, one is a real surface, and third one is a specular surface. There are three types of surface. Your specular surface, right? Second one is your diffuse surface, and third one is your real surface. What is a specular surface? If you're having one incident, it will be having only one reflection. Only one reflection. This is the specular surface. Diffuse surface means if you're having one incident, we'll be having equal amount of emissions in almost every direction. In every direction, we'll be having equal amount of emissions. Let's say this is I like this. Okay. Real surface means if you're having one incident, you will be having unequal emissions. Unequal emissions. Sometimes high, sometimes this is I1, I2, I3 like this. Okay, so diffuse radiation, we can say option A is a correct answer, because this is also we are talking about for a black surface also. Okay, option A is correct. C nahi hai. It is independent of the angle. Radiation intensity, it's your emissive power is independent of angle. Agar ye emissive power hota na, then option D would have been the correct answer. Emissive power is independent of angle and the wavelength for a black body. Okay, fine. But intensity of radiation depends upon the angle, but it is independent for a black body. Chaliye, next question. 18th. The temperature profile of a fluid in a laminar tube forced convection with constant heat flux. भाई बहुत important topic है ये, constant heat flux condition पे. If I'm talking about a laminar flow heat condition for flow through pipe, then what is the temperature profile of the fluid? Temperature profile of the fluid in a laminar tube flow with a constant heat flux, exponential, linear, logarithmic or hyperbola. Madhu, okay, very good. Anyone else? Anyone else? Madhu is going with option B, linear. Shiva is going with option C, logarithmic. Okay, anyone? Rest? Hari, Archana, Kiran? C, sure? D. Bhai, ekdam, everyone is going with different options. This is not an MSQ, it's an MCQ problem, guys. ध्यान से सुनिए क्वेश्चन को. Laminar flow. पहले तो बताइए, for laminar flow through pipe, tell me what is the value of is Nusselt number constant or variable? First of all, tell me, जो Nusselt number होता है constant होता है या variable होता है? It is constant. For constant heat flux, it is 4.36, and for constant wall temperature, that is 3.66. That is equal to constant. है ना? This is constant, and we know that Hx d by k or Hd by k, that is constant. Diameter or your thermal conductivity is not changing, so H is also constant. We know that what is heat flux, that is Hx into delta T. If I say constant heat flux, तो Q को constant होना पड़ेगा, ये तो constant है ही, तो delta T must be constant. ठीक है, delta T must be constant, and we know that if I try to plot a graph between temperature versus the length of the tube, temperature versus the length of tube, right? So initially we'll be having the, we can say, your starting your, we can say, boundary layer is not fully developed. ठीक है, तो starting में we'll be having a slight this one, then we'll be having a straight line. क्यों? क्योंकि we know that जो bulk, जो आपका wall temperature, that is linearly increasing. The bulk mean temperature, the fluid temperature should also be increasing in a linear way. Why? Because I want this delta T to be constant. Delta T को constant होना जरूरी है. That is the reason we are surely gonna say it is gonna have a linear variation. Option B is correct. Very good, Archana. Archana has given me the correct answer. Is this clear? Fine. Because we know that even if I are talking about constant heat flux, क्योंकि constant heat flux के लिए your Nusselt number is 4.36, okay, and for constant wall temperature, the Nusselt number is equal to 3.66, like this. 4.38 होता ना शायद, 4.38 and 3.66. Sir, can you explain about the convex and convex in reciprocity? Yeah, definitely. कहाँ गया? देखो, we know one thing. If I talk about three surfaces, यहाँ पे लिख दूँ? हाँ, यहाँ लिख देता हूँ. If I talk about a flat surface, if you're having a flat surface, right? For flat surface, tell me what is the self shape factor? Let's say this is surface 1. What is F11? Can you quickly tell me? For self-shape factor, what is it for flat? That is always equal to 0. Whatever radiation will be leaving, they'll all be leaving the surface. You won't be having a we can self-shape factor. Now let us talk about convex surface. If I talk about convex surface, we are having this kind of surface. This is convex. So here also we can say what is self-shape factor. It will never ever have a self-shape factor that is also equal to 0. Let us talk about concave surface. Concave surface. This is concave surface. Here we can have F11 will not be equal to 0 because there is a feasibility that will be having a self-shape factor. We can have a feasibility that there is a self-shape factor. F11 is not equal to 0. Coming back to the same question, you have calculated F11 as 0.5. So F11, it could be more precise, F11 rather than using this. F11 is not equal to 0. From there we can surely say that that is a concave surface, not a convex or a flat surface. So we can eliminate option A and B. C is the correct answer. Clear, Narendra? Okay. Okay, chalo, next question number 17 done, 18 done, 19th question. Perfect, perfect. 19th question on the screen. Air at 30 degrees Celsius is flowing over a heated flat plate having a length of 10 meter. Velocity is being given. The viscosity of the air is being given. Then kinematic viscosity. What is the variation of the heat transfer coefficient with respect to x? What is the variation of h with respect to x? You have to tell me this one. Is it minus 0.2, minus 0.8? First, you tell me, is it laminar flow or a turbulent flow? पहले तो बताइए, it's a laminar flow or a turbulent flow? Quickly. It's flow over flat plates, right? This is a flow over flat plates. Okay. So Reynolds number is equal to rho Vd by nu, or we can say velocity into your x by the kinematic viscosity. 1.5 into 10, 16 into 10 to the power minus 6. So this is somewhere around 10 to the power 6, approximately 10 to the power 6 aega. So this is a laminar turbulent, this is a turbulent flow. Turbulent flow. देखो आ जाएगा, देखो, if they have released the examination date, so definitely within 1 or 2 days you can expect the admit card, definitely. Clear Vikas? You can definitely expect the admit card. Don't worry about this. तो ये आपका turbulent flow हो गया, because Reynolds number is greater than 5 into 10 to the power 5. अगर turbulent flow है, we know that for turbulent flow, your Nusselt number, local Nusselt number is equal to 0.023 Reynolds to the power 0.8 Prandtl to the power 1 by 3, or we can say Hx x by k is directly proportional to x to the power 0.8, because Reynolds number is, what is Reynolds number? Reynolds number is equal to your v into x by mu. So x to the power 0.8 आ जाएगा. So Hx is directly, or we can directly let h, local convective heat coefficient, that is x to the power 0.8 minus 1. So h is directly proportional to x to the power minus 0.2. So for turbulent flow, we are having a relation of this. Option A is the correct answer. Kiran is correct. Kiran is the only one who has given me the correct answer. Option A is correct. Very good. Clear hai? Done. Option A is the final correct answer that we're getting. देखो थोड़ा सा logic लगाइए. If this would have been a laminar flow, then we know that for laminar flow, we know that the local convective heat transfer coefficient is equal to minus 0.5. है ना, यही होता है. ऐसे कर्व होता है, something like this, h and x, right? And definitely there is no option being left out. So by that also you can have a direct indication कि ये laminar नहीं हो सकता, it should be turbulent flow. Okay. हाँ, you have to cross verify, right? Unless until if they are giving you velocity, frankly speaking, if they are giving you velocity, if they are giving you the kinematic viscosity, then you have to check laminar flow or turbulent flow, right? Then only you can go for any conclusive answer, right? Okay. Chalo, next. Which of the following one dimension number is used for the transition of laminar to turbulent in free convection? A, B, C or D? which of the following one dimension number you're used to identify the type of flow in a fluid in free convection? Reynolds, Grashof, Peclet or Rayleigh? भाई this is free convection. Free convection आते ही Reynolds और Peclet को उड़ा दो. A and C should be the first two options that you can evaluate, because in free convection we are not having any velocity. Velocity is not evident. तो Grashof और Rayleigh में आएगा. But we know that what is Rayleigh number? That is equal to product of Grashof into Prandtl. Okay, so we can say Rayleigh number, if it is less than 10 to the power 9, that is a laminar flow. That is a laminar flow. And if Rayleigh number is greater than 10 to the power 9, that is a turbulent flow. So Rayleigh number आपको बताता है whether there is a type of flow, laminar or turbulent. अगर let us suppose, let me give you one more insight. If they are not giving you Rayleigh number, instead of that they're giving any other number, then you can go for option B, Grashof. Agar Rayleigh number, if they are not giving you in the option, then you can prefer, because Rayleigh number is product of Grashof into Prandtl. You can prefer option B. But here they have specifically mentioned about Rayleigh number, so definitely you have to go with option D. So there are many formulas. No, you have to just remember few formulas only. Like for we can say forced convection, flow over flat plates and flow through pipe. Laminar turbulent, laminar turbulent. For free convection, only laminar turbulent. That's it. There are approximately 6 and one Reynolds analogy also, the Stanton number of usage. Only 7 formulas is there that you should be knowing. Okay, there are not too many formulas. And if you try to visualize, if you remember, I have had a 20 minutes video where I have discussed the entire convection in 20 minutes. Do watch that and you'll be able to make a short notes of the convection topic. 1 or 2 page में आपका पूरा convection आ जाएगा, including the formulas. Okay, चलो next question, last question of the day. For current carrying wire of 20 mm diameter exposed to air, the maximum heat distribution occurs when the thickness of insulation is. What is the thickness of insulation? It is, they are talking about a current carrying wire. That means they are talking about cylinder. Cylinder की बात चल रही है. So definitely we can say your critical radius of insulation, that is critical radius is equal to K by H. What is K? 0.5, H is 20. That is equal to how much? Yes, 2.5 or 25 mm basically. So 1, 2, 3. 0.5 by 20 into 1000 mm. Okay, fine. 1, 2, 25 mm. Okay, now option A, B, C, D. Option A, B, C or D. Pakka? Sure? They're asking about thickness of insulation, guys. Thickness की बात चल रही है. They're talking about thickness of insulation. What should be the thickness of insulation? Anyone? Okay, so this is the wire. This is the critical radius of insulation that you should be having. It is equal to how much? 25 mm. This is 25 mm, right? What's the diameter of the wire? That is 20 mm. So we can say this is 10 mm. So you should be adding how much? 15 mm you need to add. The critical thickness of insulation is 15 mm. So critical thickness of insulation. Sir, Shiva, 2.5 mm. Are we getting 2.5 or 25? Please check. This is given in meter, right? This is meter. So this is 1 and 1 get cancelled out. This is 50, 1, 25 mm, right? Of insulation is equal to 25 minus 10, that is 15 mm. You need to add a 15 mm of thickness of insulation. Okay, right? This is given to in order to confuse you, right? So option D is the correct answer. Option D is the correct answer. 15 क्या कितना है? 15 mm is the final correct answer. Okay, fine. Option D is correct. 15 mm is the final correct, because they're asking about the thickness of insulation. D is the final correct answer. Clear hai? So this completes today's mock test on the heat transfer. I hope so everyone has solved the question, everyone has enjoyed the session, and please do let me know if you have any problem or any difficulty. And today is the mock test is going on, those who are planning for 25 gate, and on 13th of December Rakesh sir will be coming up live on our platform for talking about the time management fundas if you are planning for gate 2025. Important update, 16 December say the mock test will be started for gate examination full length mock test, so try to give that full length mock test. Along with that ये हमारे paid course already. Sir RAC class होगा, I'll be having a word with the sir, the Vipin sir is taking RAC class, ठीक है, तो अगर he is available definitely he can go for this. राइट तो ये हमारा आज का सेशन हो चुका है. नाउ दिस विल बी कंडक्टेड ऑन मंडे, दिस विल बी ऑन मंडे 6 PM 6 बजे. मैकेनिक्स सब्जेक्ट, very easy, very straightforward question from the ISRO. Okay, fine. And you can do download this PDF on my Telegram channel, that is Mechanical by Suraj. यहाँ पे join कीजिए and I'll be sharing this right now after the session. You can download the PDF for quick revision. Okay, so that's it from my side. Definitely. Safwan, I'll be definitely giving this message to him, and if possible, if he's free, definitely he'll be taking, or else if possible, I'll be taking some question of RAC in our next upcoming sessions, right, for ISRO examination. Okay, fine. So thank you guys. Do take care of yourself. Let's meet next session, that is tomorrow at 6 PM. करेंगे questions from the engineering mechanics ISRO level questions. Okay, thank you guys. Bye bye. Take care. Stay safe. Bye bye.